Welcome to Study Loop.
Hello friends, in this problem it is given a heat pump operating on ideal vapor compression cycle using refrigerant 134a or 134a. We have to calculate power input, of heat pump and electric power saved using heat pump instead of resistance heater. Let us hear the analysis. Using fluid properties of R134A by using the table 12E and A13E. In state 1, pressure P1 is 50 psi. Fluid state is saturated vapor. So enthalpy of saturated vapor at pressure 50 psia, and it is to be 108.83 VATU per pound mass. In state 2, pressure P2 is 120 psi. Entropy S2 is equal to S1 and enthalpy to be 116.64 VATU per pound mass. At state 3, pressure is 120 psia. Fluid property is saturated liquid at this state. So enthalpy of fluid at pressure 120 psia. So it is to be 41.79 VATU per pound mass. H4 is equal to H3, 41.79 VATU per pound mass. The mass flow rate of refrigerant is defined as amount of rate of heat transfer at high temperature to heat transfer at high temperature. So it is to be heat transfer at high temperature will be H2 minus H3. Power output is given 60,000. This is given in problem. Joule per second. So it is to be converted into BTU. H2 minus H3, we have to put the value as given above. So it is to be 0.227 pound mass per second. So power input is defined as mass flow rate of refrigerant into change in entropy from state 2 state 1, that is H2 minus H1. So you will get, after substituting the value, just a moment, H2 is given 116.64 minus 108.83. So on solving it, it would be 1.739 BTU per second. Electric power required without the heat pump. Is equal to rate of transfer of heat at high temperature. So it is to be 60,000 upon 3600 BTU per second into 1 horsepower upon 0.7068. So it is to be 23.58 horsepower. So power saved, power required without heat pump minus power input. So 23.58, this is in horsepower. Power of pump we have measured in BTU per second, so it has to be converted in horsepower. So it is 1.739 upon 0.7068 horsepower. So on solving it, you will get 21.1 horsepower. That's all for it. Thanks for watching it.